Hey everybody, let's see. Today let's do a simple VAV box, or let's go fan power box with SCR Heat. Nothing special here. Let's go up here, File, New. I never picked this. I'm going to put this in a 1630, so I'll leave it at 10.2. And let's go fan power box underscore SCR. Okay. This will be a VAV, single duct. Okay. Alright, now we answer the questions. It's going to be a 1630, so we're going to use the integrated damper. It is going to have a fan. That fan is going to be a parallel, temperature-based fan. So it's only going to come on whenever it needs heat. Coils, we're going to choose SCR. Most of the SCRs I deal with don't need a BO, don't need close contact. As soon as you just send it a 0 to 10 signal, it starts to cut on. So we're going to leave that off. Let's see, we're going to put a discharge temperature on here. The stat is going to be, let's do a common set point. And let's just throw humidity on there as well. And let's see, we're not going to go into, we're going to keep this one back net. And let's do discharge air reset by zone control. That's a common sequence of operation for any boxes with SCR heat. They want to limit the heat to 90 degrees or 30 degrees plus the regular air discharge set point or something like that. So let's go ahead and choose that. That's way that'll be in there for us, and that's it. Let's go here. We're not going to do any custom programming today, but we'll show you that in the future. So, first thing I always do is come over here, define hardware point assignments, and that way it puts all our points in there. If you don't do that, then none of your points will have addresses. And we'll change the addresses up here shortly. Second thing we do is we got to set all the box settings. So what we do here is you have your cool down, min flow. None of this really matters. You come down here to this one. Here's your standard set points. So if you need to change any of those, go ahead based on your sequence. Right here, cooling max flow, we'll keep that at 1,000. Cooling min flow, we'll keep that, well, we'll bump it up to 350. Say we have a larger box here. Heating min flow, let's go ahead and bump that up to 350. Again, this is all based on your box sizes, everything else. You'll set your area and your K factor from your box settings on there. That's really all we have to deal with on here. Apply. Okay. So now I'll show you kind of what everything is doing here. So if we click on discharge air tip right here, it is going to be tied to this box heating control. So if we click on that, it's going to send us over here to box heating control. As you see, we're going to heat the box depending on discharge air temp. So this is where cascading set point with the back into this. Okay, right here, 105 degrees. So the box is going to max out 105 degrees. A lot of the specs I've read here lately want to do it at 90 degrees. So what we'll do is just double click on this guy. Sorry here. Didn't open like I thought it would. And once you come down here and you set this at 95 degrees. Okay, and look, it's already backnet exposed, so you're going to be able to pull this point into your Jace. You're going to have full control over it. So this is what it's going to do is it's going to not allow this box to go over 95 degrees. And then let's go define hardware again, point assignments. So this is where you set your where you're going to hook this up to. And I'll show you. Fan command can be on a BO, right? But this heating cannot be on a BO. It's going to give me an error message because it has to be on a CO, because a CO is the only one that can do a 0 to 10 output. So we could put it on 4, or if you need to move it to 5, all you got to do is drag and drop. Or you can take it and put it over here, move its stuff around, and then come back and drop it back in where it needs to be. Same thing for fan command. Now fan command is different. You can put a fan command on a CO because the CO is a universal, right? And the fan command is a 24 volt. It's going to be a 24 volt maintained. Same thing for your discharge air temp. If you need to put it on input 2 or input 3, you can just drag it wherever you need it. That's it. The next most important part is naming your box. So this is where you would name your box for when you pull it into your Jace. So let's say it's fan power box 01. There you go. Then you have an address for it. This is your MAC address. This is your dip switch settings, which you would set right here. And your instance number. Instance number has to be unique per site, okay? Or per supervisor. If this is ever going up to a supervisor where you have multiple sites, you want to have a different instance number for every single device on that supervisor. So just keep that in mind. Maybe think of building number. This is building number 1. And then floor, this is going to be first floor. So let's go 01. And then whatever box this is, 1. So 001. There you go. There's a good instance number for fan power box on the first floor of the first building. Okay? Keep that in mind, because if you'll have conflicts if you put this on a Jace with other the same instance number on there. Well, you'll get errors. Or if you put it on a supervisor with multiple Jaces, you got to keep that in mind when doing that. And this is set up. What we can do is we can simulate it, make sure it works, make sure we never get over 90 degrees on the set point. This is the speed. And then we'll just leave all this the same. And we'll start simulation. Okay, now watch this. This is my set point. This is my cascading set point. This is going to be this. First of all, it's going to go through an auto calibration sequence, which means it's going to send the damper to 0, what it thinks is 0. And then it's going to put a default in here, put an offset in here to make that 0. Because if it thinks it's 0, then it wants to show 0 over here. So it's auto-calibrating right now. As soon as it gets done with auto-calibrating, you'll see our damper open. Okay, damper, we're calling for 350 CFM. So let's just kind of fake it out here with put a 0.04 in there. and see where that gets us. 0.04 gets us to 200, close to 200 CFM. Let's get a little bit more. 0.05. 0.05 is going to get us to 219. 107. 259. 0.1. 310. 416. So now watch the damper back down because they're calling for 350 CFM. The damper's backing down. Damper goes back up. Okay, just showing you that the damper works. Alright, so now let's go into heating. Alright, our zone set points, our common set point 72. That means our occupied cooling is going to be 74. Our occupied heating is going to be 70. So let's just drop this down below 70. 68. Okay. Well, that was quick. We got our speed set too high on this. As you see, our heating output went to 100%. But our cascade set point right now is only at 65. So, and this is going to climb. So if we put this at 70, our heating went down to 0 here. Now this is all based on a PID. Eventually it'll get up to 95 degrees. What we can do, see, it's climbing. What we can do to speed that along is go ahead and make it 1 degree cooler than what it is, 67. Farther we get away from set point, the faster the PID will go. See, 73. We're at 70, so the heating's going. Again, we're a little too quick on our simulation time because things are bouncing here. But if we go 75, we go, 76. Heating valves, our heating SCR starting to kick in again. And we have this set up for 0 to 10. So if your SCR is 0 or 2 to 10, then I'll show you how to change it here. As you see, all this is working here. We go farther from set point. And I'll show you that the set point will never be above 95 because that's what we set in there. $91. Now all these are I'll show you the logic that's going on in here. So it's all going to the PID, and this PID is actually auto-tuning, which I like. A lot of people don't like, and I get it. But see, this adaptive tuning is turned on. That means this PID is always learning, always correcting. Now it will bite you in the butt if you got a failed sensor or something like that. But it's worth it. You don't have to go in there and tune your PIDs because it'll tune it for you. Okay, we're at 95. We're gonna never go above 95 because that's what we put in right here for the max. So until we change this max, we can never go above 95 here. Show you our PIDs at 100%. See, 100% cooling or 100% heating, 95 degrees. So we're good. I'm gonna get out of the simulation here. I'm going to show you how to change this to 0 to 5 or 2 to 10 if you need to. Alright, all you got to do is double click on this point over here. You come in here. This was at 0. This was at 0. So if you want to send 2 volts out all the time, you change that to 20%. And then at 0% down here, you're going to put your meter on there and you're going to have 2 volts on your controller at all times if you change this hardware up here. So that'll make it a 2 to 10 volt signal. If you want to make it 0 to 5, change this to 0. Change that to 50%, and now it's a 0 to 5 volt signal. Depending on your SCR board, you might have to do that. So always the hardware is what it's always going to put out. Change it back. That's 0 to 10 volts. Alright guys, I think this is the end of this one. This is done. So once you complete all your programming, and you have your network settings correct in here, and you make sure the controller type's right, 1630. You come over here to transfer, and you transfer to device. You choose which way you're going to transfer to it. If you have a Bluetooth, you can transfer it to Bluetooth. If you have a map device or you're going through a Jace, you transfer it through map device or Jace. Wireless, you go through Zigbee. NAE password or pass through. This is going to be the NAE. This is not going to be going through a Jace, but this would be going through a Jace. And to do that, you put the address of the Jace in here, leave the UDP port correct, and then choose whatever network number that controller is on the Jace. And then choose your connection. This is my Ethernet connection. And then you hit next. Nothing's going to happen here because I don't have a map device hooked up. I don't have a Bluetooth hooked up, so it's not going to find this controller anywhere. So it'll fill out when I hit next. And while that's filling out, I just want to let y'all know, send me what you got. If you got a sequence of operations or drawings with the sequence on there, or even drawings without the sequence on there, if you got something weird, I'll leave my email address down here in the comments. Send me it. We'll do a video on it. I'll go through it. I'm gonna start small. Here's my air. With the VAV boxes, I'll go up to air handler boxes. I'll go up to chiller plants and heating plants. And once we get through all that, maybe we'll jump into some Honeywell. But I'm gonna stay Johnson right now because that's what I know the best. Still learning some Honeywell myself. Maybe if I can get my hands on a Jace, I'll show you, and a couple controllers. I'll show you actually loading it onto the Jace. But like I said, please like, subscribe this video. I work for Temperature Control Systems. Here's the office that I'm out of. The phone number that you can reach me on, 214-343-1444. Option 3 is automation. You get someone in automation, then if you choose option 3, someone will know what you're talking about when you talk about CCT programming or controllers or something like that. So you can reach me on that number, and I'll leave my email address in the description. So send me what you got. We'll make this interactive. Please like, subscribe. The more subscribers I get, the more videos I can do. I do this all on my own. I bought the software. This is all on my personal computer, so this keeps me going if you like and subscribe these videos. Thanks.